Oh yeah, you're right. Thank you. So to start with, I mean, for those of you, especially for those of you who are taking IT in business, you have had some exposure to the theoretical aspects of databases. Like, what is a database? It is a place where you can store your data, and then you can organize that data in the form of tables. Those tables are linked with each other, which is called relations. That's why we call it a relational database management system. That is the most prevalent approach to interact with the data. However, not the only approach to interact with the data, but it's a much better approach than physical files and logical files. It's far newer. The work for databases started in 60s, but in reality, not until 1980s, we really truly saw relational databases, even though in 70s we had them in some forms. So I know I've shared a database joke with you guys. I don't know if it makes sense to you or not. So some people don't understand databases. So that's why it's very important for us to understand some of the basics of databases. And then the bottom line is databases come from several vendors. Microsoft has its databases, SQL Server and Microsoft Access, for example. Oracle has a database. IBM has multiple database tools. One of the leading ones is DB2 UDB at one point in time. They had others as well. Then we have MySQL, which is an open source kind of a software. And then, of course, there are many, many other choices. So database and SQL, the relationship is that SQL is the language in which you talk to your database engine. SQL stands for Structured Query Language. It is the language through which you will write your questions to the database in a structured fashion. Now comes the question, what do we mean by the word query? Typically speaking, query is selecting data. But in reality, SQL is not just about selecting data, because you can only select data if somebody put that data there. So as a result, it can't be just about selecting data. So what else does SQL includes? Well, I have given you a folder under Unit 10. It is called Notes and Documents. If you click to open that, here I have given you a short definition of Introduction to Database Concepts. Go ahead and read this first. It's under Unit 10 in a folder called Notes and Documents, the very first item. So what is the other word for table?
Relations.
Relations. Okay. What is another word for record?
Tuple.
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 Tuple. What is another word for a field?
Attribute.
Attribute. Record is also called, besides tuple,
Row.
row. Okay. Field is also called what besides attribute?
Column.
Column. So these are all interchangeable words. A database is similar to the spreadsheet, but not really exactly the same as spreadsheet. And in order for you to communicate with the database, you need a language, which is SQL. Now, for example, let me bring up an Excel spreadsheet. Now, let's say if this is my data. If I do this, it's okay in spreadsheet. I can't do this in databases. I cannot just move data like that anywhere I feel like. So database has a structure, like a physical file. You first build that structure. You said, okay, my database table will have so-and-so fields. Each field will have a data type. And then you can even put restrictions on the fields, which we will not learn in this course, but in the DB2 UDB programming course, such as if you want that the gender field can only have these letters, it will not accept anything but those letters. If you say somebody's hourly salary cannot be less than $15 per hour, nobody will then be able to add anything like that. So you can add constraints or restrictions at the field level to the value level. So that's one thing. The other thing that you can do is you can link the different data sets together. I don't know if in Intro to Programming, have you guys started learning about parallel arrays? Did you guys learn about arrays in Intro to Programming?
Yeah, we did arrays already.
But you did not do parallel arrays.
I don't.
Okay, that's
Oh.
okay. That's fine. No, don't worry about it. Then I shouldn't use that example. So basically, let me use a different example. If you have a data set where it's a table and it has all the product information, and then we have another table where we have all the manufacturer information, and I want to see the name of the manufacturer for each product, I can link the product table and the manufacturer table based on a common field called manufacturer ID, which will be in both of the tables. And I am not dependent on a logical file to give that relationship to me and fetch the data from both sources. Rather, I can do that relationship at the table level, and I can fetch the data at the table level. I don't need to create another object to help me fetch the data from multiple sources. I could establish relationships with each other at the table level. It's pretty much like establishing relationship between two physical files at the physical file level, which we can't do in physical files. So that's one advantage of tables over physical files or over spreadsheets. So as I said, SQL is the language that we use to communicate with the database. SQL commands are typically divided into 4 categories. These are just categories. They don't mean anything more than that. If you want to make objects in databases like tables, users, views, schemas, indexes, permanent structures, permanent entities, you will use a data definition language command called create. So you can create a table, create a view, create a user, create a permission, create anything with create command. Some of these objects could be changed after creation. Then you do that with the help of the alter command. And some of these objects need to be removed after they're created, and you do that with the help of the drop command. So these three commands will make object level changes. So that's why this is part of definition language. If you are working at the data level and you want to put data in an object or update data in an object or remove data from an object, you are working at the manipulation level. So you're manipulating the data. So you will use insert command to add records, update command to update existing records, and delete command to remove records. Grant and revoke are permissions. These are depending on if you have rights to give permissions to other people to use your objects, or you want to take away permission from them to use your objects. For example, I want to grant Chris read access to my employee table, and Alex has read and update permission. And read permission is called select here, which is the data query language. It's not called read. And update is update permission. And to Samuel, I gave delete permission and update permission, but Samuel can't insert new data. So I can control what level of permission I want to give to which user that's granting. And once Samuel tells me, oh, I'm done with your objects, then I will revoke the permission. That kind of stuff. And select is to select the existing data that is inside the tables. Now, select is the most complicated SQL command. Why? Because remember, when you're communicating with the database using SQL, all your communications have to be done in one statement. Think about writing a program in C# where you can only write one statement. And that's it. That should be a complete program. That statement could be 10 lines, 20 lines, 100 lines, will be one statement. You can't. It's difficult. But SQL is devised such that every command has to be complete. It's not a program. It's not procedural. SQL is a non-procedural language. Non-procedural language. It doesn't have loops, doesn't have if conditions, doesn't have arrays, doesn't have any of those many things that you would enjoy in a programming language. So sometimes in select, we write a select command, and that select command has another nested select command inside it. The nested select command will generate an output which will be fed into the outer select command, and it will use that as its data set to give me my final output. And you can go 3, 4, 5, 6, however many levels of nesting you want. So inner level will produce the data given to the outer level, which will produce the data given to the outer level. Like that, are going to go all the way to the outermost, and they'll give me the output. Now think about it, that it could get extremely complicated. Single error, and it's difficult to walk through the whole SQL statement. So it can get complicated, despite the fact we have a lot of built-in features. But again, you don't have to worry about in this course. In this course, we'll be just brushing the surface. These are the data types in IBM DB2. Okay. So these data types are divided into top 4 categories, which are signed numeric, string, date time, external data. Date time is further divided into time, timestamp, date, very similar to physical files. String is then divided into It is equivalent to your character type in physical, but it's divided into varying length binary, which is binary large objects. This is where you would store your audio and video files because they are at the binary level. And then you have graphic, which is further divided into fixed length graphic or varying length graphic or double byte character large object, which is also a graphic. For example, if I want to store Japanese characters, and Japanese characters cannot be represented with a keyboard, rather each of the character is double byte, I need something double byte character to store a single character. So I will be going in as a subtype of graphic called DB character large object type. Similarly, I have fixed length and varying length graphic. So fixed length graphic would be that it doesn't matter what is the size of the image, all the images will be of, let's say, 2 megabytes. It will fix it to that size. Or varying will be like, okay, 2 megabytes is the maximum. You can go anywhere from 0 to 2 megabytes, and I'll only take up that much space. Character is also the same way. You have character and you have a varying character. Varying character is the same way as varying graphic. You set a maximum size. You can go anywhere from 0 to the maximum. It will only take up as much space. You do not have any of these things in physical files. It wasn't as detailed. Now, character large objects are typically used if you want to store the entire dictionary, maybe, or volumes and volumes of books. You're better off using a character large object for that. Then on the other side, you have numbers, which are exact numbers and approximate numbers, and you have other variations within them. And you can see that the equivalent of packed over here is decimal. An integer has 3 variations. Now, coming from C#, small int is equivalent to, let's see who can answer that C# question. With C# integer type is 2 byte large. Wendy, they're not answering. Short. Short is an integer type, which is 2 bytes long.
She didn't teach us that yet.
So again?
She didn't teach us that yet. At least not that I remember.
That probably is chapter 2 of your book.
Oh, we just skimmed the book. We don't really.
Yeah.
Yeah, I was gonna. She did teach us that. I couldn't remember.
Absolutely. That was such a long time ago. You probably don't remember. And I also vaguely remember because I last taught that class 3 years ago. I just remember the page number. I'm just kidding.
Wow.
You see Alex shaking his head up there. He's like, "Yep, she did." Now that you said it, it ring a bell. But right out of my mouth, there's no way I was gonna pull that up.
I was kind of hoping it will be like Jingle Bell, but that's okay. If it rings a bell, that's okay too.
Thanksgiving, man. We're not the jingle bells yet.
Yeah. Anyway, so small int is short. Int is 4 byte. And each byte is 8 bits. So 4 times 8 is 32 bits. Int is 32 bit, which is now here integer. What is equivalent to big int? 64 bit.
Yeah.
So we got short, int, and what is the larger form of int? It's called long. Long. So short, int, and long. Okay? Those are all integers. They do not support decimal places. Okay? Anyway. Next, what I would like you guys to do is to do some reading. Open the next 2 Word documents, one under number types and one under date and time values. And we're going to set aside 6-7 minutes for for you to read them. Whenever, if you're done earlier, give me a green check. When I get all green checks, we will move on to the next topic. Okay, so if anybody is done reading and have not yet given me a green check, please give me a green check so that I know that you're done reading. Okay, after this, I would like to introduce you to another concept, which is called the concept of referential integrity. In the concept of referential integrity, we see that the tables are linked with the common fields between the two tables. For example, the diagram that you see over here, the common field between the two tables is the artist ID. However, the problem is if two tables are linked, this is considered to be the primary table where all the artist IDs are unique. And this is considered to be the dependent table where all the artist IDs are not unique because the artist, this table is not about artists, it is about albums. So it is quite possible that the same artist could have sung multiple albums. So therefore, the same artist's ID could be available multiple times within this table. That's why artist number 3, its name is written next to 2 albums. However, the referential integrity constraint states that when the link is established between 2 tables, then the dependent table cannot have any value that is not in the primary table. So artist ID number 4 will be an error because there is no artist ID number 4 in the actual main table. So when you link the two tables with referential integrity, it forces you not to have values in the secondary source, which are not in the primary source. Okay, it's pretty much like your representation at Gateway is a student table, and your other representations is academic table or your accounts table. Now, those are your secondary representations. Your primary representation is your student table. I cannot have a student ID in the accounts table, which is not found in the students table. You know, practically speaking, there should not be a student making payments if that person is not even a student, or student having an academic record when that person is not even a student. So that's what referential integrity does automatically, forces you not to enter values which are not in the primary source. And here is another example. So we have a category table with category ID being the primary source for all the category names. An item table is where different items are placed in different categories. So there may be different items in the same category. However, in the category ID, I cannot enter a category ID that is not in the primary source. So here, the category ID in the item table is called foreign key. And the category ID in the primary table is called primary key. That concept is also not available in physical files. Physical file only talks about keys. And keys are not even unique. Keys are only there for indexing purpose. If you want the key to be unique, you have to add the word unique. Only then it forces the data to be unique. Here, when we say primary key, the primary key is inclusive of indexing, is inclusive of unique, It is also inclusive of dependency that somebody can be linked to this table based on this key. So it is far more stronger than a unique key combination in the physical file. Now, if you are wondering why is the category ID in the item table called foreign key? If you look closely at the item table, category has nothing to do with item. Category is a totally different thing than an item. The only reason category is there so that the item can be linked to the actual category table and its details. So it's pretty much like we being the US citizens are local to US, but if we go to France, what do we become? What would French people call us?
Foreigners.
Foreigners. Why? Because we don't really belong there as far as our documentation is concerned. So that's exactly why category ID doesn't really belong here as far as the documentation is concerned. It's just a representator of another table in this table to link the two tables together. That's why it's considered to be a foreign key. Okay. Now, moving back to the main unit number 10. Besides that, I've given you another source, another resource. I've given you the YouTube tutorials, a couple of them about introduction to database and introduction to SQL. One is 7 minutes and one is 5 minutes if you want to review them again outside of the class. Then I've given you a PDF document about SQL. And I've given you a web resource about DB2 UDB in particular. So the SQL tutorial, it comes from Tutorials Point. The entire 30-page PDF is about writing SQL. So it gives you the overview of SQL. It talks about what is RDBMS. It talks about normalization. Now that's outside the scope of this course. We will be learning more about the normalization in DB2 UDB. And it talks about RDBMS, SQL in terms of 4 vendors. Then it talks about the syntax of SQL, the SQL data types, the SQL operators, the expressions, the create command, drop and delete command, select command, and some of the clauses, insert command. So it just goes in detail. Now, this is only the first 30 pages of that book, which is more than enough for where you guys are standing. And then that's why I've given you the other supplemental link for the DB2 tutorial. That DB2 tutorial will take you through a multi-section tutorial, which talks about, again, different components. A lot of this is outside of the scope of this course, by the way. Only querying data is where we will be, like section 1 is enough for us. But again, as we go into advanced DB2 UDB programming course, which is advanced databases courses, that's where you will be learning about all of these. So here in this tutorial, select command is something that you can review. Insert command is something you can review. Update and delete commands. So those are the 3 commands that you can look at the basic level as far as this course is concerned. Then you have a couple of assignments this week, and all the assignments assigned to you this week are due in 2 weeks because we're not meeting next week because of Thanksgiving break. So after today, we'll be meeting back on December 2nd, which will be our last class before the finals. So that's why there are 2 assignments, one about joins and one about databases, and they're both due by the December 2nd. Okay. So that's why you have 2 assignments, and I did not give you any quiz because I'm giving you 2 assignments. Okay, now let's move on to the PowerPoints. In the PowerPoints, I've given you a PowerPoint for chapter 13, 8, and 9, but chapter 13 in the book is the chapter that mainly talks about SQL. Chapter 13, that starts from page number 652. page 652. The very first page of chapter 13, I would like you guys to read that table, which is marked as table 13.1, which tell you the differences between SQL and the traditional file access. So read the two columns, table 652, table 13.1. Okay. The next thing I want to share with you is the SQL command to creating a table. This is the syntax of how do you create a table in SQL. And the link to this is also shared with you on Blackboard. If you refresh your unit 10, it is right underneath the DB2 UDB SQL tutorial. There's a link to create table, which will open up that web page. Where was that? This one. So now the syntax of this goes like this. Create table. Create is the command. Table is the keyword. The table keyword could be replaced with views, indexes, user, whatever you are creating, but create command is there. Followed by an optional schema name. What is the name of your schema? Remember when you go to Data Explorer, you open your schemas and your schema name is exactly the same as your ID. And that's where all your objects are placed. So it is optional. You can directly just write the name of the table that you want to create. No spaces allowed. Names cannot start with a number, but you are not limited to 10 characters. Okay, you can just put many characters, okay? But spaces are not allowed. Now comes the question, okay, IBM DB2 understands object names more than 10 characters, but IBM iOS doesn't understand names more than 10 characters. So how am I supposed to use these tables on the operating system? The answer is like this. When you give your table object a name that is more than 10 characters long, operating system automatically generates a short version of that name, which is 10 characters long. And you can use that name when you're interacting within the operating system, and you can use the longer name when you're interacting from outside. Okay, so that's how it takes care of the problem. Now the syntax goes like this. You open the parentheses and you start listing your fields, your column 1 or your field 1. Now you can do data type, followed by, if you want to force a constraint that this field cannot be left blank, you can push a constraint called not null. It's actually a limitation. A constraint is a limitation, okay? Similarly, I can have another column, data type. All columns are separated by commas. And I can literally say, you know what? If the user decides not to give any value for this column will default to whatever value you want to put here, as long as that value follows the data type. Okay, so for example, he will not be putting in character value for an integer type. It'll fail. Similarly, you can put fields with data types and put check constraints like this field cannot have a value less than $15. Things of that nature. Okay, so there are multiple ways of creating columns. So this just shows you the syntax. Now let's have a look at an actual example. Okay, so we are creating a table called stores. Now that line is a little bit complicated. In a nutshell, you will learn more about this line in DB2UDB, but in a nutshell, understand it like this, that we are creating an auto-generating field. This is auto-numbered. So we do not have to enter any values for this field. It will automatically start at 1 and keep going. So this is an integer field. It is generated by default as an identity, means every record will be unique number and it cannot be left null. Then the next field is store name, the data type, the field size. Do you guys remember seeing varchar when I was showing you the data types? That variable character is a character's data type, but it allows you more flexibility in terms of storage. Like you have allocated up to 150 bytes. However, it will only take up the storage as needed. So it's more disk space saving data type. Okay. Now comes the question, why would you use character or why would you use varchar? If you're storing phone numbers are fixed in size, you're better off using character. But if you're putting somebody's name, the names could vary in length, you're better off using varchar. You don't have to use not null with every field. Like you can see address line number 2 is not null. So not null is equivalent to, if you've ever filled out a web form and it says required fields, that means you cannot leave those empty. That's what not null do over here. So if I'm mapping my database to a form, so anything that will be required on a form will be not null over here. Then it has a bunch of other fields. And primary key, it pretty much means that the following field will be used to uniquely identify every record in the table. And that's store ID. And then the closing, parentheses, and a semicolon, and I'm good to go. Okay, that's basically how the table gets created. And once you have the table created, you can then query the table by typing select all records from the table. Now, this is empty right now because we never put anything in it, but this is how you can query a table to view the data in this. This is equivalent to right click on physical file, go to data and choose return all rows. That's what this is equivalent to. You could still do that in the RDI environment, but if you're using green screen, then you would have to use something like this. Okay, so there are two ways to interact with a database. One is SQL, which is structured query language. What is the other way? I don't know if you remember from IT in business or not, but probably you don't. It is called query by example. Query by example is what the RDI does. You do stuff and it writes SQL for you. So you don't really write SQL, it writes it for you. That's called query by example. Okay, now to get started, what we want to do is we want to go to V2 Cloud. And you will give me a green check when you are in the V2 Cloud. And for those of you who are in the V2 Cloud environment, open IBM Rational Developer for I. And within the IBM Rational Developer for I, our main focus will be the Data Explorer environment or database development environment. That will be our main focus. So make sure that you double click on DeathStar and you may log into DeathStar if you need to. And also open the green screen. Do you guys remember how to open green screen within RDI?
Nope, totally forgot.
Okay. I'm still waiting for Ethan and Aiden to give me a green check. And then I'll show everybody. Okay, Ethan also got it. Ethan also got it. Okay. So now what you do is you go to Remote System Explorer, that gray color server at the top right corner. Once you are in Remote System Explorer, you will right click. Sorry, you can close that. Okay. You can right click on the Death Star, and there you can choose Host Connection Emulator. And that will open the green screen. And you can always adjust this bar at the bottom to increase the size. I'll log in to the green screen first. Right now, I am back in my database development. I'm not in Remote System Explorer anymore. So this is where I can see my tables and everything, and this is where my green screen is.
I'm sorry, could you show me again how you did that?
Yeah, so I went to the Remote System Explorer. In the Remote System Explorer, I right-click on deathstar.gtc.edu at the top, and I clicked on Host Connection Emulator. Did you find it?
Hold on. Just trying to get, it's just being very slow.
Oh, okay, that's fine. Let me know.
Okay, I got it. Thank you.
Okay. And then after that, I switched back to my database development perspective, and I can use this bar at the bottom to increase and decrease the font size here. Okay. Now in the green screen environment, when you log in, just like you traditionally log into the green screen environment, then we will use a utility called SQL. A few weeks ago, we learned about a command. How do you go about launching utilities? What are the first three letters of launching a utility command?
STR.
STR. STR SQL will launch the SQL utility. So type STR SQL and hit enter. Now your screen will look a little bit different than mine because I've worked with some commands before, but you guys should rather see a bunch of blank lines. Now this is where we can create tables. It's not state-of-the-art environment. You can write your command on multiple lines. That's perfectly okay, but should not press enter until you're done with your command. Okay, so that's one thing to be careful about. You do not hit enter until you're done with your command. You can use arrow keys to go to the next line and continue to write your command on multiple lines. So let's say I want to create a very, very simple table. Let me first of all, maybe bring a Word document. No. Here we go. A Word document. Okay. Let's think of an object. Give me a name of an object.
Bike.
Bike. Okay. Now, what kind of information can we store about bike? Give me 2-3 different set of information we can store about bike, besides probably a unique identifier that I want to call bike ID. Besides that.
Parts like the wheels, or
Price, price.
Ah,
Okay,
Color,
so again,
color.
color. Good, that's it, good enough. Okay, so I got a bike ID, a price, and a color. Now, this is very similar to your homework assignment. In your homework assignment for databases this week, you have to come up with an object and you have to come up with its fields, like things that would represent the object. Okay. Now, bike ID, typically, what do you think will be a good data type for a bike ID?
Road
like,
bike.
No, I'm talking about data type, not possible values. Data type like character, integer, date, time, what would be a good data type for bike ID?
Character.
Character, okay, because usually they are fixed. So character. What would be a maximum size you want to give to the, let's say 5. So maximum of 5 characters. Okay. Price. Likelihood is that it will be decimal. Let's do maybe 5,2. Color. Will you go character or variable character?
Variable character.
Variable characters, because colors can be of different lengths, right? Color names. So we'll have a variable character, and let's say 520. Okay. Which one of these fields you think is a good candidate for a primary key?
Bike ID.
Bike ID. Okay. It's a primary key. Okay. Are you guys following what I'm doing here?
Yeah.
Okay, now let's do one more practice here. Okay, give me another object besides bike.
car.
Something other than the vehicle world.
PC. A laptop.
Air fryer.
Air fryer is a good option. Okay, air
Nice.
fryer, good. Okay, so we can have, let's say, product ID, character, 5, primary key. Done. Okay, give me another field.
Brand.
Brand, which will probably be variable character because the different brands can be of different lengths, right? Okay, what else?
Socket type, because sockets in different countries are different.
Okay, so what would you call the data type? Character?
Sure, yeah. It'd be fixed because you could just abbreviate the country's names.
Socket type. Well, you will not going to abbreviate country names. You will put in socket type description. So what are some of the descriptions of socket types?
Number of prongs and
Exactly. So we'll basically in socket type, you're putting in number of prongs. So how about if I call it number of prongs? And then I can give it an integer type. Okay, what else?
sorry.
Wattage.
Hmm?
Wattage.
Say that again, Alex.
Wattage, like energy.
Wattage. Okay. Okay. Watts. Would that be integer or decimal?
Probably integer.
Yeah.
No, decimal. Oh, I thought it would be decimal. Should
Why?
be-
It's not
That's-
volts. We're not talking about volts. We're talking about
Okay.
watts.
Okay, I got you.
Okay. Is it free?
Price.
Oh, okay.
Only if you can outrun security.
let's not go that route. Okay. Good. Okay. As a practice, one more object.
Medication.
Medication. Okay. Medication. Okay. Okay. So we'll have some kind of a medication identification, which will uniquely identify a medication. Then what else?
Milligrams.
Okay, so we shouldn't say milligrams. What should we say? Will be a more better word.
Dosage.
Dosage. Okay. And that could be character, because it will have not only the amount, but also the unit. Okay. So I'm going to just put 10 there. Okay. What else?
Manufacturer.
Okay. I'll already put the price there, because medication without price, just, it's unrealistic. You live in utopia. Okay, so it's a manufacturer. Okay, now this could be a good example where I can create a primary key and a foreign key relationship, because we have a manufacturer. Okay, so instead of having, let me just cut this out, go to a new page, put medication here, and let's create another object called manufacturer. And now this manufacturer will be uniquely identified by a manufacturer ID. So I'm better off replacing the manufacturer name by the manufacturer ID, which will be foreign key over here and will be the primary key over here. And then I can have manufacturer name, character 20, for example, location, or I can probably do varchar instead of character for name. Okay, varchar. Okay, whatever, So that's how you can be establishing links between objects with common fields. Now I can run a query in which I want to see the manufacturer name for each of my medications. So, and besides med ID, I also can add another one, which could be medicine generic name, which anyway are written in languages that we don't understand for a reason. And medicine name. Have you ever seen doctor's notes? Like, they don't show your notes to you anymore. But in the good old days, they would give you handwritten notes that looks like only pharmacists can read. And maybe they wrote there on the note, this guy has insurance, charge him more. Or this guy doesn't have insurance, charge him less. I don't know.
Pharmacists can't read those prescriptions either. You have to call back and clarify.
I'm just, yeah, probably, Hey, what do you mean by this? Oh, this guy
That's
is
accurate.
nuts.
I work for Walgreens. I've seen it. And none of the walls are green, sir. In the back office, yeah, they are.
Oh, okay.
It's not paint.
So now let's put some of this to practice. So over here, I want to create a table, and I'll use the same syntax that I saw before. And SQL is not case sensitive, so lowercase, uppercase doesn't matter. Okay, but traditionally, if it's a command, you will see SQL developer write it in uppercase. Create and a keyword table, followed by the name of my table, bike. And then I start parentheses. Okay. Now I can use arrow keys to go to the next line, but no enter key. I can use arrow keys. So I can say bike, ID, character, 5, primary key. I could just list it right there and then. Go to the next line. Price, decimal, 5,2, not null, and color, varchar 20, close the parentheses. So the closing that I have after color is the closing of the parentheses I open on first line. So now double check to make sure that you wrote everything correctly. You have commas after every field, no comma after the last field. The closing parentheses after the 20 parentheses is the one that you started on first line. So you should have parentheses on first line. Check the spelling of create, check the spelling of table. When you're done checking everything and you are sure that you wrote everything correctly, then you hit enter. If it's an error, it will yell back and tell you that you made a mistake. If it is not an error, they'll tell you the following table was created, but was not journaled. Journaling is something that is extremely helpful in transaction processing. So maybe today we may see how you create journals and how you can add tables to the journals. For that reason, I have given you some journaling code here, and I'll talk about that if there is need be, okay? If there's a need to do that. Okay, so table created, all of you.
Mine said created but not was not journaled.
That's exactly what mine said too, if you're reading
Okay.
it, right?
Okay.
Yeah, so as long as it says table is created, but was not journal, you're good.
Okay.
Okay,
I thought it wasn't supposed to.
just
Like,
look
no,
at my
no.
screen. You can see.
Yeah,
my
I'm watching it. I'm watching it now, but I got nervous because I'm usually the guy. You know, they say if you threw a rock in a pig pen, the pig that squeals is the one that got hit. You ever heard that before?
No, I'm not a big fan of pigs, but yeah, that's right. That's probably I never heard it. Okay, so now what you can do is you can right click on the tables on the left-hand side and refresh. And open the tables. And you should see bike there in the list. And you can expand the bike and check the columns and notice you have all the columns that you created.
Tables. Should we be in the other one?
I think I told you that 20 minutes ago 4 times to go to Data Explorer. Come on.
I'm in the remote. Oh, no.
Yeah, that's what I said. At least 4 times I remember. Go to Data Explorer. Go to Data. Make sure you are in Data Explorer.
Okay.
Come on.
I don't believe you. And where you said to go?
You got to pay attention. It doesn't cost dollars, even though it has the word pay in it.
Yeah, I got that what you got right there.
Good. But yours is a little different though.
Why?
I'm just kidding. I'm just kidding. Don't. So now the next thing what we want to do is we want to add data to this. To insert data in this, the other resource I shared with you, which is the DB2 basics or DB2 tutorial. In this tutorial, towards the bottom, it talks about insert command. So insert command takes the following syntax. Insert into, those are keywords. Insert is the command, into is the keyword. Table name. What is the name of our table? Bike. Then it is optional to list the columns. It's optional to list the columns. And then you can put values. And then in the parentheses, you can start listing all the values. So if it's a character or a date value, it will go in single quotes. If it's a number value, it's going to go without quotes. Now comes the question, why in the world do you want me to list the columns? Two cases. Number one, if you want to enter data in a different format than the original sequence of the columns in the table. So if the sequence of the column in our table is bike ID, price, and color, but you have bike ID, color, and price, then you want to list the fields in the sequence in which you have the data so that it goes in the respective columns. But if your data in hand is in the same order, then you do not need to mention the column names. You can just simply add the values. I'm going to go in the respective columns. And here's an example of creating a table. Lists, for example, which has list ID, name, description, and created at. And here is an insert that talks about inserting into this. Okay. Now notice there was only one value provided, right? There was only one value provided in this case. The reason was the first field, list ID, is an identity field. It will be auto-generated. The last field, if not given a value, it will take the system time. Description, you can leave empty if you want to. So list name is the only required field. So if you put one value, that will automatically go to list name. If you put two values, that'll go to list name and description. If you put three values, the third value has to be in a correct timestamp format. We'll go to the third one. Okay, so then after making this insert, if somebody wants to see the data, they can list the fields and they can see the data. Okay. Here's an example of inserting into some of the fields. So we'll say insert into lists. I want to insert in these two fields only. So for this field, I want to put this value. For this field, I want to put this value. After that, it looks like this: monthly digest. Description is nothing. I never provided a value for it. And the timestamp is this, default. So that's how you can insert. Or you can change the sequence. You can say, you know what, I want list ID and list name. So I want to put 5 for list ID and special topics for list name. So things of that nature can be done. Okay, now let's go to our example here. So in our example, we'll say insert into bike values. In the second column, I start with the parentheses and I start listing my values. The first value, look at the field descriptions on the left-hand side. See, the color is a variable, but the sequence, the correct sequence of the field is not here. The correct sequence of the field is that I have the bike ID first, then the price, then the color, and that's the sequence I got to follow. So the bike ID is a character field, so I will include it and close it in single quotes. 1, 2, 3, single quotes closed. Comma, I can put my second field, which is price, but since it's a number, I can just put it without single quotes, comma. I can put my third field color. It's a character in single quotes. So let's say red. Now close the parentheses that you open at the beginning of the line. Make sure that you have written everything correctly, and then you hit enter. Insert into bike values. Now it says that one record was inserted correctly. Now, if I want to insert another record, I need to press F9 and my previous entry comes up. And I can now make just some changes like making it 113, making the price maybe 150.99, and maybe changing the color to blue. And enter. Another record get inserted successfully. And I can right click my bike, go to data and return all rows to see if it has data in it that I entered. So once you're done adding that, just right click on bike, go to data, return all rows, and check it out at the bottom. It has the data that I entered right here. Okay. So that's the insert command. After learning about the insert command, we will learn about the update command. The update command allows you to update the existing data. So you write update the table name, set.
Sorry, mine says token was not valid.
Okay. Like you were not able to insert any records or what?
The second one.
Second one. Okay, check the syntax to make sure you, when you were overwriting it, you made correct changes. So you have to follow the syntax closely.
Okay.
What if you wrote it like, can you go back to it? If you, let's say you rewrote it down and then you want to go back to it to fix it up.
I mean, did it go through or no?
It did go through.
If it go,
I just didn't write down, I wrote down 113 on the first line instead of 123 for red.
Oh, okay. So if it went through and you want to fix it, then we do that with update command.
Oh, okay.
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 So I'm zooming in so that you guys can see the values in case if you have any errors. That the syntax goes like insert into table values, parentheses, and all values are in parentheses separated by commas. Character values are in single quotes and number values are without quotes. So if you make an error in the insert, you can fix it and then it will go through. But if it went through and you want to change it, then you do that through update command.
Yeah, I made an error somewhere. I'm trying to see where.
Okay. And if you want to get rid of it, then you use delete command. So yeah.
Yeah, I don't know where I made a mistake.
Say it again.
I don't know where I made a mistake. It looks correct.
It looks correct. Okay, let's have a look at it. Maybe you're missing something or overlooking something.
Yeah. share my screen.
It is not on my end yet.
No, let me share it.
Yeah.
You see it?
Okay, now this is what you are missing. You are missing the whole instruction. You only wrote part of the instruction.
What did I?
Okay, so I will share my screen to show you what you're missing.
Okay.
Okay, you only wrote the second line. You didn't write insert into bike values. You didn't
Oh,
write that. You
Okay.
have to write both lines.
Oh, I got it. Okay, I got
Right, yeah, because it doesn't carry over from what you wrote before. It needs
Okay.
the complete instruction.
it. Okay, I got you. So how do I go back?
Just delete this line, the one in front of you.
Is there a command or just?
No, go ahead. First, delete the line that you are on right now. Just use the regular delete key. And when the line is empty, let me know.
Why is not letting me delete it?
Okay, share your screen. I will stop sharing when you share your screen. Okay, now hit the backs, of course, where your mouse is, you have to, where your instruction.
Oh, I thought you said.
Come
my
on,
fault.
that's keyboarding. Come on.
I thought you said hit the delete button, so I'm hitting
I don't
the
know where
delete.
your insertion point. Okay, so now you press F9.
F9. See, that's the thing. I switched keyboard and it's messing me up.
Okay, then if the F9 is an issue, did you try function key F9? If that doesn't work either?
Yeah, let me try it. Yeah, there you
Okay,
go.
now try again, function F9 again. Yes, that is the correct format. Now go to the second line.
Okay.
Okay, now start replacing the 1, 2, 3 with 1, 1, 3.
Alright.
Just put 1 there, just type 1. Okay, now use your arrow keys to go to 250. So go to the number 2. Type 1. It will override the 2. Go to 6, 6, the first 6, the leftmost, and then type 9, 9. Okay, go under R for red and type blue and put single quotes and put closing parentheses and hit enter. Here you go.
Okay, sir.
Now on the left-hand side, you see bike, right click
Yes,
on
sir.
bike. No, bike, right. No,
Oh.
the table name bike, not bike ID.
All right, that's what I was
Okay,
doing.
so right click on bike, go to data and click return all rows. Okay, now you may have to increase the window at the
Bottom
bottom.
side.
Yeah. Yep. Yep. And that's where it shows you the 2 records that you inserted.
Okay.
Okay. Now you can bring it down so that you can see your green screen better.
Yeah, this thing's weird. See why I didn't want to change it to black? Because it's hard to see.
Okay. So now let's switch to the update command. So update command syntax goes like this, that you type update followed by the table name, followed by the word set, followed by the fields that you want to update. If you're only updating one field, you write field name equals to a value. If you're updating multiple fields, then each field will be separated by a comma and no comma after the last field. If you do not write the where, then it will update all your records. For example, if you say update bike, set the price equals to 35, it will update everybody's price to 35. So to avoid that, you can use the where clause and say, you know what, update bike, set the price to 35 only where the bike ID equals 112. So only 112's price will change. So that's what the where clause does. Now let's have a look at an example of update here. Update lists. Set the description to general topics that sent out daily. However, if we do not put the where clause, everybody's description will change to that. But if we only want to update the first list ID, we will say make this change only where list ID is 1. So only that list ID will be updated. So when we now do the select all, so you can see that only that one record got updated, everybody else is still null. Similarly, you can do a multiple record updates as well. I want to update the table lists. I want to set the description equals to n/a, where the description currently is null. So all these nulls will change to n/a's. So you can update one record, or you could update multiple records. It totally depends on your query. You can update one field, or you can update multiple fields. That also totally depends on your query. So now let's go back here. And let's say if I want to update the price of the bike only for 1, 2, 3. So I will type update bike. On the next line, I'm typing, not that I have to, for clarity purpose, I'm doing on multiple lines. Set the price equals to $99.99, where the bike ID is 1, 2, 3. So update bike, set the price to $99.99 only for bike ID 1, 2, 3, and hit enter. And it should tell you that one row updated. Now, to check to see if the value really got updated, there are two ways. One is you right click on the bike and you go to data and return all rows. Another approach is the SQL approach, which is you type select asterisk, which means all the fields from the bike table. Select asterisk, which means all the fields from the bike table. Hit enter. Now I'll take you to a different screen where I'll show you that 1, 2, 3, the new price is $99.99. Okay, now you can hit F3 to exit out of this screen and go back to the previous one. So this is how you can see in SQL how the data looks like, or what the data looks like. Now let's press F9 twice until we see the update bike command again. And now we will update multiple fields. I want to update the price of the bike ID 1, 2, 3 to $89.99, comma, and I want to change its color to purple. And then hit enter. So the color is purple and the price is $89.99 for the bike ID 123. So multiple fields are updated. To check to make sure that the fields are updated, we will use select star from bike and hit enter. And you should now see that the 123 has the price of $89.99 and the bike color is purple. It's not red anymore. Okay. Now press F9 again, twice. And this time we will update multiple records. So let me get rid of the where clause. I want to increase all the prices by 10%. I want to increase all the prices by 10%. So I will write a formula. Set the price equals to the current value of price multiplied by 1.1. The first one is the current price and 0.1 is the 10% increase from the current price. Simple formulas you probably would have written in Intro to Programming as well. For example, calculating overtime rate. You take the hours worked multiplied by times and a half. Similar idea. Enter. You're about to alter all of the records. This gives a warning. Enter to confirm. See, this is a security measure. It's like, maybe you made a mistake, man. You're about to alter everything. So that's a good feature. Now that when you said, yes, I am interested in doing so, now you can hit F9 twice to go back to select star from bike and hit enter. And you should see now that price of the first bike is being jumped up from $89.99 to $98.98. And the price of the second bike has also jumped up from $150 to $166. F3 to go back to the previous screen. If I want to delete one particular record, that will be part of the delete command. So let me go back to the delete. Delete command is written in this format, delete from table. If you do not write the where clause, everything in the table gets deleted. But if you only want to delete certain records, you write the where clause, such as, I want to delete from lists where list ID is 1. So only that record is deleted, and now list ID 1 is gone. So delete from lists where list ID is 1. So only the 1 is gone. Rest is still in place. If you say, I want to delete multiple records, delete from lists where list ID in 2, 3, or 4. That means if any one of them is there, delete it. So it will delete 3 records as a result, 2, 3, 4, everybody's gone. Okay, so now let's go to our data set and we will type delete from bike where bike ID is 1, 2, 3. Delete from bike where bike ID is equals to, in single quotes, 1, 2, 3. And only that one record will be deleted.
I don't want to interrupt at all, but for some reason, I don't see my tables anymore.
Oh,
Like,
like on the left-hand side?
my schema is it's all gone. I don't see, I just see the Death Star and the schemas and that's it.
But are you able to run your queries okay?
Yes,
Okay,
but I didn't do any of the right clicking on the bike or anything like that.
don't worry about it. I'm not doing right clicking anymore. I'll look at it afterwards.
Okay.
Yeah, just continue to do the SQL. I'm doing strictly SQL right now. So once your record gets deleted, you can do F9 to select star from bike. And when you hit enter, only one record should remain in the table. And 1, 2, 3 should be gone. So only 1, 1, 3 stays and 1, 2, 3 is gone. If I want to delete everything in the table, nothing should be left behind, then let me get rid of the where clause in my previous query. So I just wrote delete from bike and hit enter. Everything is gone. It tells me, are you sure you want to delete everything? Yeah. And now when I do, oops, F9 on select, the table is empty. So how many SQL commands did we talked about so far? I'm looking for a number, how many?
3.
4, create, select, delete, and then insert. Missing. So
Don't give me names, please. Give me the number.
oh, okay.
I said, give me the count.
Yeah, let me give you a count here. Let's see. 1. It's 5, 9, 10.
5.
5 is the correct answer.
Yep, 5.
Okay. So we did. What are those 5?
I can't tell you. You told me to give you a number.
Now it's the next question.
Delete, update, select,
Uh-huh.
insert,
Uh-huh.
and create.
And create. Very good. Okay. So if I raise it to this level, then it's high 5.
And you're going yourself. Can I use a battery, man, or?
Oh, you need the biological bricks.
Yes.
Yes, that's what we'll be taking next. So let's take a break till 8:05. And then when you are back, we will then move on to other tools. Yeah, and Bart, you can close RDI. We don't need RDI anymore. And everybody else also, you can close RDI. Okay, guys, welcome back. Now that you guys are back, let me refer you to some of the pages in the book where it talks about some of these commands. So page number 686, which is right after figure 13.3, 13.30 is right after that. It talks about the insert statement. And you can look at the variations on page 687. And you can see that how the syntax is shown and a couple of examples is shown to you. That's page number 687. Then if you turn to page 688, you can see the update command. And at the bottom of page 689, you can see an example very similar to ours. In this example, the author is updating the employees table and is changing everybody's salary by 6.5% increase. That's what he's doing. That's why he's doing 1.065. Everybody's salary is going up by 6.5%. Only in the MIS department. Then, if you go to page 692 in figure 13.35, that's where you can find the delete command. So on page 692, it is delete from EMPPF. That will delete everything. And then page 693, delete from EMPF only where the current date is greater than birth date plus 40 years. Okay, that's discrimination to a lot of people. I'm just kidding. Deleting all the 40-year-olds.
I think there's an Elon Musk joke in there somewhere.
Probably. Anyway, so those are the 3 commands that your book talks about in that area, and talks about the select command on page 653, which is figure 13.1. Select star from EMPPF. And the author is using the same utility that I was using, STRSQL. And what you see on page 654 is the utility that I will use next. In figure 13.2, this utility is a Windows-based utility, not a 5250-based utility. It is called Run SQL Script. Okay. And the newer versions of Run SQL Script are color-coded as well. Anyway, to get started, let me share my screen again. Now I will create this medication table. Okay. But before I create the medication table, I would have to create the manufacturer table. Why? Because medication table has a foreign key. And the foreign key requires that the primary key be created before. Otherwise, it doesn't know, what am I foreign to? You know, who am I representing in this table? So that's why the primary key table is created first, and then the table that has the foreign key gets created. Okay, so everybody, you can close RDI. We don't need RDI anymore. You can now open on the desktop ACS. Again, in the ACS, once it opens up, we will not be going to the 5250 emulator. So let's wait till ACS opens up. At least on my end, it is a little bit slower for some reason that I don't know.
Yeah, mine's booted me all the way back to the start, so I'm logging back into the.
Okay. So let me know when you guys are in and you have opened the ACS. You know, I don't know. I mean, I gave you guys a little bit of a shorter break today and went all the way till 8 o'clock because we're not meeting next week. So I got to cover 2 weeks worth of stuff in 1 week. So I'm going slightly a bit faster than I would traditionally go.
It's all good. It's just now that my V2 close is just acting up.
what I sometimes do is I refresh this window where my connection is, and then try to click on the connect button again. And it works mostly when I do that.
Okay.
So that allows it to reestablish the connection. Because every time you refresh a web page, it requests a web server to refresh the contents. So it just sends the refreshed contents to the client's computer. Let me know if that worked for you, okay?
You said that we're booting up ACS, right?
Yes, we are. Once you're in, double click on ACS, which is Access Client Solutions, and you will see the window that I'm on right now. And then I have not given any other instructions.
Okay, it's loading.
It's loading. Okay, when it's up, let me know. And everybody else who has not yet given me green checks, as soon as your ACS loads, please give me a green check. So I believe only Chris is left. Okay. Got it, Chris? The ACS? Oh, okay.
I got it. So
Okay, cool. So now when you are in ACS, I want you to click under databases on Run SQL Scripts. When you click on Run SQL Scripts, it will ask you to log in. So you will log in. And once you log in, it should tell you that you are connected to so-and-so database. And on the title bar, it should actually tell you Run SQL Scripts, deathstar.gtc.edu. So do you guys have the similar thing as I do, or is it any different?
Yes.
yeah, it looks just like yours.
Okay, okay.
Yes.
Now, when it says untitled, the reason is all the work that you will do over here, you can actually save it to a local computer. So I mean, like to the V2 Cloud, from there you can transfer to any computer. So we can actually, and it will be an SQL file.
If you're talking, we can't hear you.
Oops, can you hear me now?
Yes.
Oh, okay.
I
So,
thought my headset died again.
thank you. So you click on File and hit Save As and PC File. So we are trying to save this SQL file, and we would like to name it. So I'm naming mine as November 11th, 2022. And then all the work that we will do here, we can save it for future. So it's not like str SQL utility where just things comes and go. It can be saved as a file, which could be transported, shared, exchanged, whatever, and hit save. So now you can see that the untitled is now changed with the name of the file on the title bar. Now we will start creating the tables. As I told you that this will be the first table that I'll create called manufacturer with these 3 fields. So what is the command to create a table? Create command. So create, notice it's color coded. So if it's a keyword, it will be color coded. Create table. The name of the table is manufacturer. I can hit enter in this editor. It will not run the command for me. And I can use parentheses and I can start listing my field names. And make sure you put semicolon at the end of the I'm trying to look for, okay. Under view menu, it has font. And that's where you can choose the font size. Mine seems bigger fonts than probably on your screen for that very reason that I went and increased the font size to 26. So if you want to do that, you can do that as well. It's under view and you can then click font if you want to increase the font size. So all the keywords are blue color. All the data types are italic and purple. All the number values are olive. And anything that is not system defined is black. Other than operators. Operators are also black, like parentheses and comma. I'm just waiting for everybody to done typing, and then I'll show you how you can run this command.
That's a semicolon at the end, right?
Yes, that is a semicolon in the end, correct.
All right, thank you.
So in this environment, we put semicolon, but in the SQL script, in the SQL utility, we don't put semicolon. So let me clear your feedbacks, and only those people should give me feedbacks who are not done. Okay. So if you're not done, that's what that represents. So as soon
My fault. That's like I heard that wrong. I am done.
oh, you're all okay. So I can clear the feedback.
Yes.
Now you select these 4 lines, and you can see the line numbers is also there. And on the toolbar, you see 4 hourglass symbols, right? The first one, if you hover over, says run all. If I have multiple SQL commands, I can run them all at once. The second one says run from selected. So if I have like 10 SQL commands, but I only want to run 5 through 10, then I can select 5 and I can click on the middle one. Now I'm going to run 5, 6, 7, 8, 9, 10. But I'm not going to run 1, 2, 3, 4. And the third one says only run the selected. So I only want to run the selected. So click on that one. Click on the third hourglass symbol. It will run it and it'll tell you the system ran successfully. Again, it gives you the same warning that it gives you in green screen that the table is not journaled. Okay. Now, let's check to see if the table really exists, right? So we can do select star from, and I can actually copy paste. Select star from manufacturer. Then you
No, no space,
say again,
no space in between.
in between what?
Like select
Select,
star. Yeah.
there's a space, select space, star space, from space, manufacturer. Then you select this line that you just typed, and then you can hit that third hourglass symbol, which is run selected. So only that command will run. And it'll tell you that the table is created, but it's empty. Nothing is there.
Sorry, I'm having an error. My manufacturer on line 3 is highlighted in red and said could be.
Oh, okay. Now, did you put a comma after the word primary key?
Oh, no. Thank you.
Then you said to run this.
Yeah, the second command, just select this, the select line number 6, and then hit the third hourglass symbol, which reads run selected. And that will give you the output that I see down below here,
I got that.
which is an empty
Which
table.
is an, yeah.
Yeah. And the good thing is when you hover over the fields, look at it. It tells you the field description there. What is the data type and what is the field size? And if it's nullable or not, and things of that nature. Okay.
Are the spaces on 3 and 4 just to make it easier to read, or do you need
Yeah,
those?
it's only for readability purpose.
That
That's it.
doesn't
Okay.
affect it.
I could have written all these 4 lines on one line also, would not make any difference. So these 4 lines are just for the readability sake. Okay, now let's do insert commands in this environment. Insert into manufacturer values. And I have a character field, manufacturer ID, manufacturer name, and location. So got to make sure, again, let me space out so that you can see the spacing. I don't know if that's better. The commas at least are a little bit readable on before. Okay. So I will select that line and I will click on the third hourglass symbol and it'll tell me that 1 row was inserted successfully. Only run line 8. Do not run everything. So select and then click the hourglass symbol. And make sure that all 3 values are in single quotes because all 3 values are character values.
My insert just highlighted red.
Your insert is highlighted red. Did you make sure that you have a semicolon on line 6 in the end?
Sorry.
Okay. It's because if you forget to do semicolon in the command above, it thinks that both of these commands are together. Got it?
Still have an error.
Still have an error? Can you check again? You have insert into, the table name is correct, matches exactly. Values, parentheses, all three values are in single quotes, separated by comma, close the parentheses, semicolon.
Yep.
Yep. You want me to have a look at it?
Sure.
Okay. Aha, you missed a comma. After the sans corp, single quotes, there should be a comma between the two single quotes. No. After sans corp, yep, right there. Yep. Now select and run selected. Awesome.
Thank you.
Mhm. Okay. Now you can copy line number 8 and paste it 3 more times. Okay. And the good thing about this editor is it doesn't overrides. So I can just type and make changes however I want to do it. I'm not running anything. I'm just making changes right now. Whenever you guys are done inserting, I mean, like making edits to lines 9, 10, 11, then select all 3 of them together. Select all 3 of them, 9 all the way down to the end of 11. And then click on run selected. And it should run each one of them one by one, tuck, 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 right? And then for each one of them, it will give you one final message that 3 statements ran successfully. So you can run multiple statements like that in this editor. Also, once you are done entering the records, you can simply select line 6 again and run it. So you don't have to retype it. Just select the already typed line and run selected. And they're only going to run that line. And here you can see all 4 lines of output, all 4 lines that you inserted. Again, it's up to you if you want to do your homework assignment in this, or you want to do your homework assignment in green screen.
Mine is giving me some error.
Okay. Can you share?
Yeah, 1 second.
Okay. Okay. Did the first one ran? Okay, do one thing. Oh, you are running all. That's the problem. Hold on a second. Don't do that yet. Run line number 6. Only run line number 6. Select line 6 and run it. Okay, you already have 101. Okay, now select lines 9 through 11. and run it. It's fine. I know my presence makes things wrong sometimes.
Thank you.
Oh, it's the power of hard work.
I'm having an error. I ran it and it was running. I had an issue on line 11 and then I ran it on line 6 and then now I have an issue on line 9.
Okay, can you share your screen, please? Can you please run line 6 for me again? Okay, actually, if you scroll down in the list, you have the first 3 records already inserted. So only run the last line 11. Because of the primary key, it is giving you the error that the, okay, maybe 104, hold on a second. Oh, okay, the length is longer than 20. You wrote Cali and Blue Corp. So get rid of one of the corps. Okay, now run line 11 again.
Thank you.
Yeah, man, you gotta get rid of the corpse, man. You can't save the corpse.
There you go.
Here the corpse.
Now run line 6. Yep, and then you can scroll down in the list
Got it.
and
Thank
you
you.
should have all 4 of them.
Thank you.
Mhm. Got it, everybody?
You said you have kids, right? Sir?
Oh, you asking me?
Yeah.
Oh, yeah, I do. Just for you, this, Desmond.
What?
I am having some issues.
Oh,
For
sure.
some reason, I mean, when I scan it from 6, it works. I can see all of it there.
Mhm.
But then when I try scanning it 8 through 11, it doesn't. It's just popping up errors. I'm not
See,
understanding it.
if line number 6 shows you that all 4 records are there, that means the records are there. You cannot insert the same records again because it is causing duplicate records. Are all 4 records there when you run line 6?
Yeah.
Yeah, so that's why lines 8 through 11 we will only run those once to insert the data in the table. Once the data is in the table, we are running line 6 only to make sure that the data is in the table. When you're trying to run lines 8 through 11 again, it is causing a conflict because we said manufacturer ID is a primary key and primary keys do not allow duplicates. Since you already have 101, 102, 103, 104, it won't let you insert those again.
Okay, I see.
Okay. So that is why the insert will fail if the ID key already exists in the table. Okay, so now that everybody is done with the insert, let's move on to creating our second table, which will be the foreign key table for this table. So that table we said will be medication table, and the medication table will have med ID, medicine generic name, medicine name, and dosage and price and manufacturer. There will be a lot of data items there. Okay, so that's our next table. I can create, oops, I can just hit enter here a few times to create extra rows. Create table, medication, parentheses, med ID, now this is the field manufacturer ID. That will be my foreign key. So this is the field where I have to make sure that the field description matches 100% with the manufacturer ID in the primary key table. So that's why I will be putting here the same description, care for. Okay, now I will build the primary key foreign key relationship. And this is the syntax. Constraint the name of the constraint, foreign key manufacturer ID. Constraint type is foreign key. The local field is manufacturer ID. That is the foreign key. Which references the manufacturer table, which has the primary key. And that completes the syntax. It's a slightly longer syntax. Constraint, constraint name, constraint type, constraint field, references, primary table, and the primary key field. Then I'll select these lines and I'll run it. Oops, I made a manufacturer ID. Did I make a mistake here? Manufacturer, oh, foreign key. Maybe it goes in parentheses. One second. Yep, I forgot to put it in parentheses. That's what the problem was. Put this in parentheses. Manufacturer ID after foreign key. I just ran select star from medication just to make sure that the table exists and it's empty. And then we will be needing that select command as we insert record and data in it. So anyway, we'll use it many times. If you have any errors, check the lines to make sure there are some basic elements. Everything that's blue color coded for me, you should have those blue color coded. All lines should end in commas, no comma after the last line. On the last line, I mean. And if you still couldn't figure it out, let me know and then we can have a look at it.
Sorry, we select all lines?
Yeah, select, no, well, yeah. Are you talking about creating tables?
Yeah,
Oh, okay, yeah, of course, because this is all one table.
right, okay.
Yeah.
I got a statement ran successfully with warnings.
Yeah, that's fine. As long as you can see that green line that says statement. That's why I asked everybody when you're done creating the table to write line 22 and then run it to make sure that you can see your table, even though it's empty.
Thank you.
Do I run the first part first and then do the select
Yes,
from?
yes, yes. So that we can maybe sure that the first part doesn't has any errors, and then we can run the second part.
The statement ran successfully.
Okay, then code line 22 and then run that individually by itself. Because once the table is created, if you rerun the same statement again, we're going to complain and say, object already exists.
Okay. All right, I'm all caught up.
Okay, is everybody all caught up? Okay, so we will now start the insert command on this table. And again, I have to make sure that when I put my foreign key value for manufacturer ID, it has to be one of these four. Otherwise, it'll yell back. And we will test that as well. We will purposely enter a value that doesn't exist in the primary key so that you can see what error it generates when it yells back. Okay, so insert into medication values. All the character values will go in single quotes. I do not know many names. I'll just make up some of this stuff. Okay. So I have 1, 2, 3, 4, 5, 6 fields, and I got 1, 2, 3, 4, 5, 6 values. I'm matching the data types, character, 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 character. So first for our characters, then I have a number, which I put like price is a number, no single quotes. And the manufacturer ID is a character. And then it is one of the values that I have in the primary key. Select it, run it, and it ran successfully for me. Everybody got line 24 working? Or let me ask it the other way around. Who doesn't has it working? Okay. Besides Chris already told me that he's working on it. Anybody else still working on line 24? Chris, you got it now?
I got it.
Okay. So everybody got it. Okay. So now we will copy line number 24 and I will paste it maybe like 2 more times. And I'll change the ID. So I'm adding 2 more records, 25 and 26. So I added 1 more medication, but with a different manufacturer. And I added 1 more medication with the same manufacturer as the first one. To show you that foreign key can have duplicates, but primary key cannot have duplicates. But all the values in the foreign key must match the data set in the primary key. Once you are done with all 3 records, you can select all to make sure that you have the 3 records in the table. So everybody made sure that they have 3 records when they ran line 22 after running lines 25, 26. Got it, everybody?
I'm still
Chris?
working on it.
Oh, Chris, you're having an error?
Yeah, I'm having an error.
Okay, have a look at it. Okay, Desmond, you're still working on it, right?
I'm just about to run mine. I'll let you know.
Okay,
Mine's rendered.
okay, cool, awesome. You want me to look at yours, Chris, or you can do it yourself?
Yeah, I'm gonna take a look because I'm.
Okay, I can have a look at it. That's fine.
Someone else is sharing. It's not a. Oh, here we go. Sorry, that was you.
Me, the culprit.
Oh.
So, okay, you should not run that again because you already ran it once. You should only run lines 25 and 26 because of the primary key. You cannot insert the same record. See, it is telling you it contains duplicate values. So only run 25 and 26. Yep, you're good. And now select line 22 and run it. There you go. You got it. Okay. So just so that you guys, I know it's new stuff for you guys. The primary key cannot be duplicated. So if you already ran a record with the primary key already and it ran successfully, if you run it again, it will give you an error. And that is the keyword to look for. If it tells you duplicate keys, that's what it means. You're trying to insert the primary key value again. Now, let me copy line 26 and paste it on line 28. I will leave the ID to be 3 again. Just watch, don't need to do this. Just watch, okay? So I'm duplicating the primary key. Select this, the last like line 28, and I will run this. And notice the error. The keyword is duplicate key value specified, and the field can only have a unique value. As soon as you see that error, that's an indicator that you are trying to insert a primary key value that already exists. Okay, now second thing, I want you to pay attention to, again, don't do this, just watch. I'm putting a unique primary key, but my foreign key value, I'm putting 105. Remember, I only have 101, 102, 103, 104. I don't have 105 manufacturer. So when I do not follow the referential integrity, that's the word, referential integrity. So you run this and notice the error message, operation not allowed by, look at the keyword. See that keyword? Anytime you see referential keyword, that means you're entering a value in foreign key that is not to be found in the primary key. Okay, so what are the 2 different errors I told you about? Who can repeat those?
Duplicate key.
Which means
Then
what?
when you're trying to run the primary key again.
And the second error is?
Referential constraint.
And which means?
That there's a line that doesn't exist. Essentially, right?
Say it using a little bit better words. Entering a foreign key value that does not exist in the primary key.
One key value is not.
Okay, so foreign key value that doesn't exist in the primary key will yield to referential constraint error. Okay, you don't need to do this line. I will delete this line. I just wanted to show you guys what errors will come if you go this route. So yeah.
So say if you know, like you spell the name wrong and you already run it, you would then have to do update and then.
The command never ran. See, I still have 3 records.
Right, but say that you spelled something wrong in that record.
Yeah, okay, let's see. Let's do one like that. Let's say I misspelled actifite and I want to fix it. So I will run, is that what you're asking, right?
Yeah.
Okay, so I will update the medication table and I will set the field called med generic name to, let's say the correct spelling is actifite, where my primary key med ID equals to 1. It will update it, and now let me run it. And here it shows the actifite spell change. So you will run it, the updates will happen without a problem, the same way as would be with any other table.
Sounds good. Thank you.
So what are the concepts we learn about in the databases today? We learn to create a table. We learn to insert records, update records, delete record, select records, right? Now let's learn to remove a table, drop a table. So let's drop the bike table. So we will type drop table bike. That's it. Drop table bike. Select it and run it. And the bike table is gone. If you do select star from bike and you try to run it, it will give you an error, that file not found. That's another third kind of error. If you're trying to access a table and you run into this error, file not found, it means either you misspell the table or the table name doesn't exist, because sometimes you can misspell a name and it'll be like, oh, I created this. So check the names. Everybody was able to drop the table bike? Okay. Now, if we go back to unit number 10, you have one homework assignment, which is about joins. You already have done this, right? You already created the publisher table with the books and have populated it with data values, and that's what you did in the last two assignments. So you're basically only solving this problem. You are joining the two tables and selecting these four fields. And you're creating the join between the two of them based on what we learned in chapter number 8 and what we covered last week. So if you go to the last week's unit, you will have the class recording, and you will have this video, which talks about how you join logical files. And then there is also an example in the book on page 359, which is figure 8.19, which shows you how things can be joined. So you can use all those references to solve the problem. So that's page 359. And then the second homework assignment under unit number 10 is, I'm asking you to open a Word document, and it's exactly like the way we did this, right? I want you to come up with an object name and then list 5 properties. So list 5 properties like here. For each property, come up with a data type. So think of an appropriate data type and size. And then after you are done with this, then translate that into a create command and then insert 4 records in that table. Now, let me update this. I want you to and length and field size, and then insert 4 records using SQL command insert. Okay, SQL insert command, I should say SQL insert command. And please screenshot of your table SQL and insert commands. Your create table SQL command, insert commands, select all the data that you inserted and screenshot the output of select command. So basically something very similar to what we did over here, that after we insert the data, we run the select. And as you run the select, it shows you the output. So I need the screenshot of the select command and its output. I need your insert commands, and I need your create command. So basically, I'm asking you to give me pretty much all of what we did here: create table, select table, insert table, and the output.
And you said this automatically saving while we were doing it?
All of these are saved objects. These are getting saved under tables in the RDI. You can check them, but the SQL is not saved until and unless you save it in a file like I did today.
Yeah, that's what I'm asking. Since
Yeah.
we did a file, is it all
Yeah,
going?
if you save that file, that towards the end of the operation, you need to click file and hit save again, because notice my file has a little asterisk next to its name. So that means it's not saved. So I can save my file, and you can when you come to run SQL script, you can start a brand new file. You don't have to add it to this file. And then you can also, if you want, you can upload that script if you don't want to take screenshots.
Okay.
Okay. So for example, when I save this, mine is saved on the desktop. So here is mine, November 19, 2021. So if I want to reopen this, I launch run SQL script and I go to file, open, and then it's a PC file that I want to open, and I can just click on November 11th, and here it is.
Yeah. Got you.
Okay. So we are not meeting next week. Again, just wanted to remind everybody, and you have 2 homeworks to work on. And the soccer World Cup starting in Qatar. It's not Qatar, by the way, it's Qatar. A lot of people misspell and say Qatar. A long time ago, people used to say, you know that country I ran? I said, I never ran to that country. The country is Iran. And the country is not Iraq. I didn't rack anything. It's Iraq.
Did
Iran and Iraq. Of course, when you run undirectionally, you will wreck.
have a good Thanksgiving to Ethan.
And I wanted to ask you guys, this is the most interesting game. Okay, when turkey gets marinated, and then the turkey plays hungry.
I wonder if you plan these things before you come to class. Is that what's
No,
going
I just did it while you guys were doing the example. I was just looking at the World Cup schedule, and I'm like, oh my God. Okay, so Turkey is not even there. Hungary is not even there. Chile is not even there. I'm like, oh, it's not even yummy this year.
So corny. Um,
So anyway,
what was I gonna tell you? Oh yeah, funny question for you. I think you heard this question before. If we don't do the assignment, can we still pass this class?
you are asking as a joke? Or are you asking for real?
No, I definitely do my assignments. I'll just be silly. I was
Don't
trying to.
see those people. Let me tell you very clearly, those people who don't do their assignments, those are the ones that fail the hands-on.
Okay.
Okay, because the assignments are in alignment with the hands-on part of the final exam. So if you do not know how to join the physical files in through a logical file, you will just miss out on all those X number of hundreds of points.
Yep.
Okay, if you do not do the database part, you will miss out on the entire database hands-on part on the final. So that's why it's important, if you can complete the assignments, that will be a great way for you to have a practice of doing a similar problem hands-on final. So there are people, frankly speaking, there are people who are like, oh, it's only 100 points, I can easily pass. And then they see the final and they're like, oops, how do I do this? And then they fail that. Then they, because of that 100 points that they wanted to skip, now they drop from B to a D.
Dang.
Okay.
Couldn't be me.
Yeah, because they didn't do any hands-on on the final exam. They just did the multiple choice, and they didn't even score 100% on the multiple choice. Then they didn't do a few assignments in the end, thinking that I'm already a B, I can easily be okay even if I get a C. So they missed on those 500-600 points, and boom, they're down. Yeah, so people do that. You know, towards the end, they're like, okay, how many assignments can I miss and I will still be okay. Don't do that to yourself ever.
I'll try not to. I'm trying not to be a hungry turkey playing chili, you know.
Absolutely, absolutely. Yes, Bart, go ahead.
So